Hello students, today we will discuss a few examples related to the integration by parts. Okay, so first question is integration sine inverse x upon 1 minus x square to the power 3 by 2 dx. So first what we will do in this question, we will apply the method of substitution to simplify this. Let sine inverse x is equal to t. Now we will differentiate, so we will get 1 upon under root 1 minus x square dx is equal to dt. That means 1 upon 1 minus x square to the power half dx is equal to dt. Now we can put these values in our integration, so we will get from here, if sine inverse x is equal to t, so we can write x is equal to sine t. First we will write our integration like this: sine inverse x upon 1 minus x square and 1 minus x square to the power half dx. Now we know that this dx and 1 minus x square to the power half is equal to dt. Now we can put these values here, then we will get sine inverse x is t. From here we can see sine inverse x is t upon 1 minus x square, and the value of x is sine t. So 1 minus sine square t, and this value is dt. Now t upon 1 minus sine square t is equal to cos square t. How we know this? We know one equation, that is sine square x plus cos square x is equal to 1. So if we take this sine square x to the right hand side, we will get cos square x is equal to 1 minus sine square x. So we can put these values in our integration, that is t sec square t dt, because we know this that 1 upon, what we know, 1 upon cos square t is equal to sec square t. Okay, now we can apply method of integration by parts. So for this we will check which function is first and which function is second. For this we know we apply this ILATE rule, ILATE. So this t is algebraic function, so it will correspond to a, and sec square t is trigonometric functions, it will correspond to t. So t is first function and sec square t is second function. Now we will recall the formula. What is the formula? Formula is here, first into second dt is equal to first second into dt minus differentiation of first with respect to t and integration of second and integration of their product, right? So we will apply this formula here. Now first function is t integration sec square t dt minus, now differentiation of first function, that means differentiation of t, d over dt of t, integration of second function is sec square t, and integration of this the product of these two. So what is the formula of integration of sec square t? It gives us 10t. T into 10t minus integration of differentiation of t is 1 with respect to t, 1 into, and integration of sec square t is 10t dt. Now we get t into 10t minus, and integration of 10t is log sec t plus c, and plus c in the previous one. But our given question is in terms of the x, right? Here in terms of x, so we want our answer to be in the terms of x, not in the terms of t. So what we will do, we will put the values of t here. So what is t? T is sine inverse x. So t is sine inverse x, and what is 10t? Okay, we can find the value of 10t. If sine t is x, so cos t will be, cos t is under root 1 minus sine square t. So cos t will be under root 1 minus sine t is x, so 1 minus x square. So we can find the value of 10t. 10t is sine t upon cos t. So value of sine t is x upon under root 1 minus x square minus log sec t is, okay, we can again find the value of sec t also. Sec t is 1 upon cos t. That means 1 upon under root 1 minus x square plus c. This is your answer. Next question. Next question is integration x square tan inverse x upon 1 plus x square dx. So first we will simplify this. After that we will apply integration by parts. To simplify this, what we will do, we will let t inverse x to be t. Now if tan inverse x is equal to t, if we differentiate, differentiation of tan inverse x is 1 upon 1 plus x square. So in the left hand side we get 1 upon 1 plus x square dx is equal to dt. Okay, so here this is clear that this dx term and 1 plus x square term will be replaced by dt, and we need tan inverse x will be replaced by t, but here there is one more term x square. For this we need the value of x in term of t. For this we can find from here x is equal to tan t. Okay, now we will put all these values in our given integration together. So x square is tan square t, and tan inverse t is simply t, and this is dx upon 1 plus x square is dt. Now we can apply first and second, but we know that integration of tan square t we can't find it by any formula. So what we will do, we will convert it into the terms of sec square. So we know one equation. What is the equation? 1 plus tan square x is equal to sec square x, or x is variable here, so this can be replaced by t also. So 1 plus tan square t is equal to sec square t. Now we want the value of tan square t, so it will be sec square t minus 1. So first we will replace this. So tan square t is sec square t minus 1, and we have here t into dt. Now first we will separate these two terms. So here we have two terms, sec square t and 1. So first we will separate. After separating, we get sec square t into t dt minus t dt. Now we know that integration of second term, this second term is very easy, so we want to focus on this first term. So here we will apply integration by parts. So again we need to check which one is first function and which one is second function. So we will apply this formula ILATE. In ILATE, t is algebraic function, so t is first, and sec square t is again trigonometric function, so it is second function. Now again we recall the formula, first into second, dx is equal to first outside the integral and second inside the integral minus differentiation of first function and integration of second function with respect to x and integration of their product. Now we apply this formula here, so we get t sec square t dt minus differentiation of t is 1 and integration of sec square t is tan t, as we have done in the previous question, into dt minus integration of t dt is t square upon 2 plus c. Here we have applied this formula, integration of x to the power n dx is equal to x to the power n plus 1 upon n plus 1 plus c. Now t into integration of sec square t is tan t minus integration of tan t is log sec t minus t square upon 2 plus c. Now we can put the value of t here. So value of t is tan inverse x. So tan inverse x into tan t is here x minus log. Okay, what we can write sec t in terms of t. Okay, we from here, from this equation, if we check, or from, okay, not from here but from here, from this one, sec t is equal to under root of 1 plus tan square t. So we know now what is sec t. Sec t is under root of 1 plus tan square t, and tan t is x. So 1 plus x square minus t is tan inverse x. So tan inverse x to the power 2 upon 2 plus c. This is your answer. Okay. Now next question. Next question is integral x e to the power x upon x plus 1 whole square dx. Okay. What we will do here, first we will simplify this. To simplify this, I will add 1 and subtract 1 in the numerator. So here we are given x, but what am I doing? I am adding 1 and subtracting 1 into e to the power x, because here 1 minus 1 we get 0. So by adding 1 or subtracting 1, we do not change the meaning of integral, the meaning of numerator here. Here x plus 1 square into dx. So now we will separate these two terms. First we will take x plus 1, and second we will take minus 1. So x plus 1 e to the power x upon x plus 1 square dx minus, so now minus 1 term, minus 1 into e to the power x is minus e to the power x upon x plus 1 square dx. Okay, and again when we simplify this, what we get? We get e to the power x upon x minus x plus 1, because we have power 1 of x plus 1 in the numerator, and here we have power 2, so one power cancels one power in the denominator. So e to the power x upon x plus 1 dx minus e to the power x upon x plus 1 square dx. Now we will apply first into second, but before that we will write it like that. So we have 1 upon x plus 1 into e to the power x dx minus 1 upon x plus 1 whole square e to the power x dx. Now again we will decide which one is first function and which one is second function. For that we will check isolate. So this 1 upon x plus 1 is again algebraic function, and e to the power x is exponential function. So this one will be first function and this one will be second function. Yes, in here also this is first and e to the power x is second function. Now we will apply the formula. So first function 1 upon x plus 1 is outside the integral e to the power x dx minus integration d over dx. Okay, here we I can notice one interesting thing, that we will not solve the second integral, this second one, because I can see here that when we will differentiate this 1 upon this 1 upon x plus 1, so we will get minus 1 upon x plus 1 square. So we will not solve the second one, but we will solve only this first integral only, and second one will be cancelled out. Okay, let us check. So differentiation of this and integration of e to the power x dx, and then integration of their product, and we have this second term. This is integration of 1 upon x plus 1 whole square e to the power x dx. Okay, now we solve this. Integration of e to the power x, integration of e to the power x dx is e to the power x plus c. So this is e to the power x upon x plus 1 minus integration of, now differentiation of this 1 upon x plus 1 using the chain rule. This is equal to minus 1 upon x plus 1 whole square and integration of e to the power x is e to the power x dx, and second term here is 1 upon x plus 1 whole square e to the power x dx. Now we solve this. E to the power x upon x plus 1 minus minus plus e to the power x upon x plus 1 square dx minus e to the power x upon x plus 1 square dx. Now we can clearly see that, okay, here we can write plus c. So this term is cancelled out by this term. So eventually our answer is e to the power x upon x plus 1 plus c.